Inverse trig functions and their graphs. When we want to find the inverse trig function, that means we've been given the sine, cosine, or tangent value of an angle, but we need to find the angle itself. So for example, using the unit circle, we can find that the answer to the sine of 30 degrees is 1/2. Remember, in the little parentheses, sine is the second number. So at 30 degrees, the sine is 1/2. Turning that around gives us the inverse. We would say that the inverse sine of 1/2 is 30 degrees. So we're trying to find, we already know what the outcome is, we're trying to find the angle. So the answer is always the angle whenever you're dealing with inverse. Sometimes besides the little -1 beside the trig function, which means inverse, you also see arc in front of the trig function. So arc sine, arc tangent, arc cosine is the same thing as the little -1. It just all means inverse. There are restrictions to where you're allowed to look on the circle for inverses for them to still remain a function. So for inverse sine and inverse tangent, you're only allowed to look at the right half of the unit circle. For inverse cosine, you're only allowed to look at the top half of the circle in order for it to remain a function. So that's what we'll be doing on these problems. We're asked to find exact values. That always means use the unit circle. We're going to answer in both degrees and radians, which is what I would like you to do for your homework. And so first we're doing the inverse cosine of 0. We're trying to figure out at what angle is the cosine 0. Where do we see this? A 0 first in the parentheses where the cosine is. We're only looking at the top half of the circle. So this happens at 90 degrees where the cosine is 0. So we would say that it equals 90 degrees or pi over 2. We want degrees and radians. The arc sine of square root of 3 over 2. Sine is the second number in parentheses. So we're looking right half only at the circle to find where sine is square root of 3 over 2. That happens at 60 degrees. The sine is square root of 3 over 2 at 60 degrees, which is also pi over 3. Arc tangent of the square root of 3. The tangents are written out by hand around the outside edge of the circle, so we want to find on the right half only where tangent is square root of 3, and that happens up also at 60 degrees, or pi over 3. The inverse sine of square root of 2 over 2. So we're looking and trying to find where sine is square root of 2 over 2, right half of the circle only. That happens at 45 degrees. So 45 degrees or pi over 4. Inverse cosine of 3. Cosine is the first number in parentheses, so we're looking where we can find top half of the circle only, the cosine being 3. So you can spend some time looking, but you're never going to find that. Think about the trig graphs. For the parent trig graphs, both sine and cosine never go above +1. They never go below -1. So you cannot have an inverse of anything higher than +1 or lower than -1 because the graph does not exist there, or sine and cosine don't exist there. So for that one, you would just say undefined. We used inverses a little bit in an earlier lesson, and we learned that trig functions and their inverses cancel each other out. So if I've got the cosine of the inverse cosine, those two things just cancel, and I'm left with the square root of 3 over 2. Or if I have the inverse sine of sine, those cancel, and I would just be left with pi over 4. But look when you have a combination of two different trig functions. You'll want to evaluate the inside one first. So the inverse tangent of the square root of 3. I want to look on the circle find where tangent is square root of 3, and that happens at pi over 3. Now, stay at pi over 3 and find the sine. It's not inverse this time, it's just regular. Sine is the second number in the parentheses, so it's square root of 3 over 2. To draw the graphs of inverse functions, if you'll think about how we found inverses algebraically earlier in the course, to find the inverse, you switch the x and the y. So this is true for graphs of inverse. If you have the graph of a function and you switch all the x and y coordinates and regraph, you have the graph of the inverse. So to do graphs of inverse trig functions, we're going to swap what we did have on the x-axis and what we did have on the y-axis. What was on the x-axis was our scale, pi over 2, pi, 3 pi over 2, and 2 pi. So that now becomes our y-axis. On the y-axis, for the regular trig functions, we had positive 1 and negative 1. Now those are on the x-axis. We know that sine starts at 0, 0. That's still going to be true. And we know when we went to the right, we went up. That's still going to be true. 1 and pi over 2 go together. Then it crosses, below, and crosses. Lower, crosses, higher, crosses. Now be careful, some people think that the inverse graphs are just the regular graphs rotated. They are not. The x's and the y's are swapped. It's not a rotation. Y equals inverse cosine. So cosine, the parent graph for cosine starts up at positive 1. This graph will also start at positive 1. Crosses, lowest, crosses, highest. And there's inverse cosine. And then finally, for regular tangent, we had vertical asymptotes at pi over 2 and 3 pi over 2. Those will now become horizontal asymptotes. And they're on the negatives as well. And remember, the tangent graph crossed the x-axis at all the other marks, so now it's going to cross the y-axis at those places. And then the curves look like this. And just repeat over and over in between the horizontal asymptotes. And that is inverse tangent.